Good evening and welcome to the South Florida Writers Association's holiday edition of the Authors Showcase Series, a virtual experience. My name is Beverly Malassie-Haig and I am your host for tonight's performance. But before I introduce our featured author, I'd like to share a little about us. We are a 501c3 nonprofit educational and membership organization dedicated to literary arts and support writers in our community. Our mission is to establish and maintain a forum of fellowship, education, and information among writers in the South Florida area. For more information, please visit our website at southfloridawriters.org. Tonight, the South Florida Writers Association is pleased to showcase author Peter Luykx and his book, The Patchwork Human, 2 billion years of evolution. Life on our planet began about 4 billion years ago. The miracle of evolution stitched human beings together from parts of an ancient species now long extinct, like an old patchwork quilt. As a result, humans literally have thousands of traits that have been passed down throughout time. Peter's book explains how we as social, sexual, language-obsessed technological apes evolved into our modern species. Peter has lived in academics throughout his adult life, teaching and doing research in biology, specializing in genetics and evolution. He has given many public lectures and has published dozens of research articles and book chapters on the subject. The Patchwork Human is the second book in the first of a non-technical readership. May I present to you Dr. Peter Luykx.
Hello, everyone. My name is Peter Luykx. I'm happy to have this opportunity to talk about my recently published book, The Patchwork Human, 2 billion years of evolution. I'd like to thank the South Florida Writers Association and Books and Books, and also Beverly Malassie-Haig for helping arrange this presentation. As the title says, this is a book about human evolution. I've tried to make it free of jargon as possible so that it can be read by anyone, whether or not they have any scientific or biological background. This book started out as a standard college textbook, but after a while it seemed not so interesting to do that. And so after some false starts and a lot of background reading and finding a really good scientific illustrator in Kate Baldwin, the book ended up in its present form about 5 years after its initial start. Now, I'm not going to read sections of the book verbatim, but I would like to share with you some of the topics that are covered in the book and show you a number of the illustrations so that you can get a flavor of the book. So let's start with some illustrations and I'll give some explanations as we go along. Okay, so here's the cover of the book, The Patchwork Human, 2 billion years of evolution. Why 2 billion years? Well, life on this planet probably began quite a bit before that with just single cells, almost 4 billion years. But it wasn't until about 2 billion years ago that individual cells got together and cooperated to form larger multicellular organisms, and of which we are one now, 2 billion years later. So that seemed like a good place to start 2 billion years ago when multicellular organisms first arose. So why a patchwork? Well, it was customary in days past, and still it's done now, is to take old and new pieces of scraps of cloth and put them together and make a quilt. And it's even become something of a fashion statement. So you can make clothing that way, not just quilts, but actual clothing. Now imagine that it's not just our clothing, but actually our bodies that are put together in the same way or assembled that way. They may not have arisen that way, but at least that's the outcome. So we have parts of our bodies that are really old, evolutionarily speaking, and some that are quite new. For example, if we go around counterclockwise, a really old feature of us is having a head and the mouth and the sense organs all at one end here. Later on, vertebrates arose, and so we have a backbone. Later on, among mammals, when mammals arose even later than that, we have hair and milk glands. Primates, which arose as a specialized mammalian group later, we have opposable thumbs, flattened fingernails. Later, upright walking, characteristic of us and some of our evolutionary ancestors more recently. And finally, a trait that is really unique to human, the large brain that we have and language. So one could add other traits, but they do fit together now in our present form, even though some of them are very old and some are very new. So that's the way our body is assembled, as a kind of evolutionary patchwork of old and new parts. So that's the reason for that title. So I'm not going to read parts of the book verbatim, but I would like to show you some of the topics that are covered in the book. Early on, I do have a brief discussion of what life is. And life is a molecular arrangement. There used to be an idea, and it's still current among many people, is that the mere physical frame isn't enough to make life, and particularly human life, that there has to be something added to that. And that, in fact, was one of Mary Shelley's ideas in writing Frankenstein, is that you could get the physical frame of it, but something had to be added. A spark of life had to be added in order to make it truly alive. But that isn't necessarily so, and it's not the current belief. Here's an example to illustrate why that's the case. On the left, we have, in this sort of analogy, we have a bunch of molecular parts, and they don't mean too much. But if you assemble them in the right way, something new emerges, as you can see on the right here. So nothing has been added, but if the molecules are arranged in the right way, you can get life. So one of the early features is our bilateral symmetry. And you can see that, of course, in our silhouettes. You can see it not only in the external appearance, but also in internal features as well. We have 2 kidneys, 2 ovaries, 2 testes, 2 adrenal glands, 2 lungs, and a lot of the internal organs are arranged one on each side. So that's bilateral symmetry. We only have 1 heart, and that's an interesting story, because embryologically, the single heart we have originated as 2 separate structures, 2 enlarged blood vessels that then fused together and folded to become the single heart. It'd be nice to have 2, but embryologically, we ended up with just 1, but it originated as 2. So internally and externally, we are bilaterally symmetrical. So what's the origin of that? Well, we know it's very old. We have here a fossil that's almost a billion years old, and that's been discovered, and that's its shape. It's bilaterally symmetrical. You could cut it in this plane, and what's on the right side is the same as on the left. There is a small worm, modern organism that's been discovered on the seafloor of the North Atlantic. It's a little worm, very small, but it's got the same shape, and it crawls around, moving forward on the seafloor. And we ourselves, in the about 3 weeks after conception, have the same shape. We are bilaterally symmetrical at that early stage and has the same form as some of these animals that are very simple now and some very ancient ones as well. So our bilateral symmetry originates that way. Interestingly, we like bilateral symmetry in our architecture as well. Maybe we have this yearning for way back before we were even human to return to our bilateral symmetry, that simple organism. But we do like it in our architecture, and you can see that here. And also, we use our bilateral symmetry here. Here we return to the water. That's our ultimate origin, is the oceans, evolutionarily speaking. And here we have a young man taking his love out onto the water and using his 2 arms and 2 hands to row the boat. And so there's our bilateral symmetry still in action at this time. So when you're in the audience and applauding, remember why you have 2 hands, so that you can applaud. It's because way back, millions, hundreds of millions of years ago, your ancestors were simple bilaterally symmetrical organisms slithering across the floor of some ancient sea. Another feature that is quite old is reproduction by sex. Sexual reproduction is very widespread among animals and even plants. And let's look at that. Now, some organisms, some animals reproduce asexually, and plants as well. They simply bud off parts of themselves. And wouldn't it be nice if humans reproduced that way as well? We wouldn't have to bother with these useless males. A woman could simply bud off parts of herself, as she's doing here, and those parts could simply develop and grow up, and you wouldn't need any males at all. This is how human reproduction could occur if we reproduced asexually. But we don't, and in fact, most animals don't reproduce that way, although some simple ones do. So the question is, how come? Now, it turns out sexual reproduction is really inefficient, so we do need some explanation for why it arose, and we'll come to that. To show you why sexual reproduction is inefficient, imagine a situation, very artificial situation here, in which there are 2 females, Aphrodite and Virgo, and they each have resources enough to have 4 offspring each. And let's compare sexual versus asexual reproduction. Aphrodite reproduces sexually, so she produces 4 offspring, 2 of which are females and 2 of which are males. Now, having only 2 females means that at the next generation, those daughters will each reproduce and produce a total of 8 offspring, 4 of which will be female, 4 male, and so on. After several generations, there'll be a doubling in the long run. So after 6 generations, she will have produced 128 great-great-great-great-great-grandchildren. Now, contrast that with Virgo, who reproduces asexually, no males. So she has 4 daughters. Those 4 daughters can each produce 4 daughters of their own. So at the next generation, there'll be 16 offspring, and so on, 64, 256, 1024. So after 6 generations, her offspring will have vastly out-reproduced the sexually reproducing Aphrodite. So why aren't all organisms on the face of the earth reproducing asexually, since it's a much more efficient way of producing offspring? We need an explanation for that. Well, here's the explanation. It really has to do, reproduction by sex really has to do with mixing genes from 2 individuals. That's what it's all about, not reproduction per se. And here's what happens. You have two different individuals. One produces a small cell with one set of genes, and the other individual produces a larger cell with a set of genes. And the genes are likely to be similar, but somewhat different because these are two different individuals. They get together in forming the fertilized egg, also called a zygote. So we have combined in a single cell, which ends up being multicellular, and then an offspring that contains genes from two different parents. And that's what sexual reproduction is really getting genes together from two different individuals. And so here's what's going on. Once you have an individual like this one with genes from two different individuals, something special can happen. And here's what's going on. This is a chromosome, which is a long string of genes. That's the way genes occur in all of the cells of our body. And in the testis or ovary, in making the cells that will become the next generation, there's a special kind of process that breaks parts of chromosomes and reassembles them. So imagine that we all carry some defective genes around. Imagine a situation where you have individuals or chromosomes from two different individuals. They're not likely to have exactly the same bunch of bad genes. So a gene up here that might be bad on the chromosome from the father might not be the same as the gene down here, a different gene on the chromosome from the mother. In the formation of the cells for the next generation, there's this breaking process. And so you can see you can reassemble a chromosome in a sperm or an egg that is free of those. Of course, there'll be some bad ones, but at least you can make a chromosome that is free of the defective genes. Similarly, the same process, if there happen to be some particularly good genes on separate chromosomes, that same process will get those good genes together on the same chromosome, which will be passed on to the next generation. So for both these reasons, we can get combinations of genes that are better than were present in the previous generation. And that seems to be the advantage of sexual reproduction. Mixing genes in order to get better gene combinations. Now, here's another related subject. It has to do with whether the behavior of the males and females, since we do reproduce sexually, is it better to be promiscuous or to be faithful in looking for a mate and in mating with a mate? So here's another situation that's instructive. Imagine that there are some genes in males that make them promiscuous. So it comes down to their producing a lot of sperm cells, whereas women can only produce an egg at a time. But the male has the potential of impregnating and fertilizing eggs from a lot of different women. And so there'll be a lot of offspring that could carry the genes that he has. On the other hand, if the male were completely faithful to the woman he has chosen, he can have only a number of children which are produced by an egg at a time by his mate. So you can see in the long run, what you'd expect is there'd be a lot more children carrying promiscuous genes than in faithful genes, if we can call them that. Now, the situation for a woman is very different. If she has a gene for being promiscuous, and so she allows her eggs to be fertilized by sperm from a number of different men, she won't have any more children than she would have if she were completely faithful. She does have a choice as to what male she wants to mate with. But in general, the difference is that promiscuous behavior, which is actually seen all over the place, promiscuous behavior by males is seen all over the world among animals. It's very common. Not so much with females, and that's the reason, is that promiscuous genes get passed on to more children than faithful genes. Okay, what about the future of our species? What does that hold for us? Well, one way of getting an idea of what the future might hold is to look at our evolutionary past. Here's an evolutionary tree, and all of our human-like ancestors, which are known from fossils. We can reconstruct a tree, and we know roughly how old these fossils are. A particular species like Homo erectus here has a particularly long life. The early fossils are quite a bit older than the later fossils of that same species. So we can get an estimate of how long Homo erectus lived. And that's true for all of these other human ancestors. And here we are, and we're wondering about the future. One thing we can do is from fossils, which have been dated, get an estimate as to how long these different species lasted. How long did they persist? And the answer is, on average, of course, there are some that didn't last so long, some that lasted longer. On average, each species lasted about 1 million years. So if that applies to us, we are about 1/3 of the way into our 1-million-year existence, if that's what it is going to be. So anyway, 1 million years is about the average existence of our previous ancestors. And that could be, if we are typical, that could be our future as well. Of course, we're not typical. So the question is, would our technology allow us to survive and not go extinct the way our ancestors did much longer? Or are we going to use up our resources fast and go extinct sooner than average? So we don't really know that. What could be the end of our species? One possibility is there's a meteor strike, a major meteor strike that wipes our species out the way the dinosaurs were wiped out 65 million years ago by a massive meteor strike. But geologists and cosmologists tell us that meteor strikes of this nature are not, are not that common. They occur only every 50 to 100 million years. So it's not likely we'll go extinct that way. Another possibility is that we evolve. With rising seas, we may have to adapt to that, evolutionarily speaking, and turn into some creatures like this. But that's not likely either. And that's because the pace of environmental change, such as rising seas, is too fast. These creatures here, human beings, and this creature here, a seal, had a common ancestor way back. And it took about 50 million years for the species to evolve into these two different forms. And so that's 50 million years is way longer than the average existence of human-like species. So we're likely to be long extinct before we could ever evolve into anything like this. Maybe we could colonize other planets. The conditions there, of course, would be different, and it wouldn't be too many generations before we evolved into some other creature that's not quite human. And of course, that could happen theoretically, although the distances between us and some habitable planet are immense. But nevertheless, if it did happen, these human descendants would, of course, adapt to their new environment, and they wouldn't really be us anymore. So we would be extinct, but we would leave some descendants extinct as a species. Now, more likely is that climate change will do us in. Here's a reconstruction of the temperature that has been obtained by various physical methods. And if we look at the periods of animal extinctions shown by these shaded bars, we can see that they correspond to climate change, not to a particular temperature. But when there are climate changes, then animals go extinct. So there's a correlation between animal extinction and climate change. Now here we are over at the right-hand end. And let's magnify this a little bit more. And here we see that the temperature is rising fairly rapidly in our present era. Here's where the Industrial Revolution started in the late 1700s, early 1800s, and CO2 levels and global temperature has been rising ever since. This is probably the most likely scenario for the extinction of the human species. So time will pass and we will use up our resources, and the climate change will deplete our resources, and wars and starvation will lead us to a few roving bands of humans that will eventually go extinct. Maybe in a few thousand years, this is what human civilization will be reduced to, and that will be the end of us. That seems, from our present vantage point, the most likely scenario. Well, these are all issues that need further discussion, and if you would like to see more details about this and other facets of our evolutionary past and why we are the patchwork that we are, you can get my book, The Patchwork Human, from Amazon or from the publisher, McFarland Books. So thank you again to the South Florida Writers Association and Books and Books for arranging this presentation, and thank you for watching.